Problem number 4. So we have the series from n equals 1 to infinity of 1 over the square root of 2 raised to the n minus 1. So I'm looking at this and I see two issues kind of right off the bat. This doesn't start at n equals 0, it starts at n equals 1. And this exponent here is not to the n, it's to the n minus 1. It looks geometric, and it certainly is geometric, but we need to do a little work on this to be able to figure out what it converges to. So I'm going to show you a couple of tricks. So the first trick I'm going to show you is similar to the trick we used on number 2 where we split up this into two pieces. So I'm going to write this as 1 over the square root of 2 to the nth power times the square root of 2 to the negative 1. So that negative 1 is going to make this pop up to the numerator. So this is really equal to the square root of 2 over the square root of 2 to the n. So that's going to make my series. I'm going to put an arrow there because they're not going to be equal, but an arrow indicates this is the work I've done that now tells me my series is going to be from little n equals 1 to infinity of root 2 over root 2 to the n. So this piece doesn't have an n on it, so I can pull the root 2 out in front, and I have this series from little n equals 1 to infinity of 1 over root 2 all raised to the little n, which is totally fine to do because 1 raised to the little n is just 1, so that still works out just fine. So that's one trick, splitting that denominator into two pieces. Another algebra trick we can use is to multiply this by the square root of 2 over the square root of 2. So that gives me the square root of 2 in the numerator because that's 1 times the square root of 2. And in the denominator, I have the same base. These are both square root of 2. This is raised to the n minus 1 and this is raised to the 1. And so we would add those together. So I get n minus 1 plus 1. So that gives me the square root of 2 raised to the n. I'm going to put an arrow here to show that now switching over to my series. So this is going to tell me that my series is going to be the square root of 2 times the sum from n equals 1 to infinity of 1 over root 2 to the n. Okay, so the good news is these two are the same. So that's a happy smiley face. And then let's see, now this is a geometric series. So I have, here's my C and here's my R. So I know I have a geometric series and the absolute value of R is equal to 1 over the square root of 2. And if you aren't sure what that is, I put that in my trusty calculator. And that is between negative 1 and 1. So we know that this converges. Okay, so I have a convergent geometric series. The absolute value of R is equal to 1 over root 2, which is less than 1. To get what it converges to, I need to find my first term. So my first term happens when little n is equal to 1. So I always have this square root of 2 out in front. And then when n is equal to little 1, I get that that's multiplied by 1 over square root of 2. So that's equal to 1. So that tells me that this is going to converge to the first term, which is 1. Over 1 minus r, so 1 minus 1 over the square root of 2. Alright, so that looks great. Both techniques work. Here's a third technique, and if you go on to differential equations, and I use this trick quite a bit in differential equations, I really want this to be to the n. I'd like this to start at 0. So what I'm going to do is I'm going to replace this n minus 1 exponent with a t. So I'm going to let t be equal to n minus 1, which tells me that n is equal to t plus 1. So I just solved this for n. And then I made some replacements here. So I replaced n with t plus 1, and I replaced the n minus 1 with the t. And so if I subtract that 1 over, I get t equals 0, which is good. That's what I wanted it to start at. And I have 1 over root 2 to the t. And this is going to simplify to the sum of little n equals 0 to infinity of 1 over root 2 to the t. Whoops, this should be a t down here. Sorry about that. So the sum from t equals 0 to infinity of 1 over root 2 to the t. So again, there's my r. So this is a geometric series. Absolute value of r is equal to 1 over root 2, which is less than 1, so we know that converges. So this all checks out. And then let's make sure it converges to the same thing. So I do have my r. My first term here is going to happen when t is equal to 0. And anything to 0 is 1. There's no other number out in front, so my first term is 1. So this will be equal to the first term of 1 over 1 minus 1 over root 2. Okay, so we get the same thing all 3 times. So this is just another way of tackling this problem. All right, so geometric series are a form of series that you're going to recognize just by looking at it. So if we look at our flow chart for our series test, the first thing you want to check for is, do you have a recognizable form? So do you have something that looks like a number raised to the n? If you do, that's a geometric series. You can apply this test and then you're done, right? And when we come back, we're going to look at a few more tricks to do with this.